The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. My name is Rick Rector, publisher of Security Systems News, and I want to welcome you to today's webcast entitled Video Compression and Cost of Ownership. This webcast is produced by Security Systems News and sponsored by ONVIF. ONVIF was founded in 2008 by Axis, Sony, and Bosch to create a global standard for the interface of IP-based physical security products. The organization was developed to provide increased flexibility and greater freedom of choice so installers and end users can select interoperable products from a variety of different vendors. In its early stages, ONVIF members were from the manufacturing industry only. In recent years, membership is open to consultants and systems designers, systems integrators, and end users. To date, ONVIF has a global member base of established camera, video management system, and access control companies, and more than 10,000 profile conformant products. Before I introduce our speakers, a quick housekeeping note: we welcome and encourage questions. There's a box in your control panel where you can just enter your question, and we'll get to as many of them as we can at the end of the presentations. We have two expert presenters for you today, and this should be a very, very interesting presentation. I'm looking forward to it. Let me introduce our speakers in the order in which they'll speak. Per Bjorkdahl is the current chair of the ONVIF Steering Committee and has been since the fall of 2012. Per is involved with ONVIF's conformance initiatives and represents the member-driven organization as a speaker at trade shows and other technology events and to the media at large. His professional career includes a lifelong commitment to technical convergence with Axis Communications and companies like TAC, now part of Schneider Electric, advocating for the acceptance of communication standards in the building automation industry. Per has worked in the physical security industry for more than 25 years and was an early supporter of IP technology within the industry. Per is currently Director of Business Development with Axis Communications, a position he's held for almost 20 years. Our second speaker is Stuart Rawling. Stuart is head of segment marketing for Pelco by Schneider Electric, based in Clovis, California. Prior to focusing on key segment growth in his current role, Rawling was the Pelco executive team member responsible for technology partnerships and product interoperability. Starting in 2010, Stuart has been helping drive standardization in the physical security market, working closely with ONVIF and other organizations. In 2014, he was elected as the chairman of ONVIF's Communication Committee Group, and in 2016 was appointed to the ONVIF Steering Committee. Stuart holds degrees in computer science and software engineering from the University of Stirling, Scotland, which explains why he doesn't have a California accent. So with those introductions, on to our presentations. Take it away, Per.
Thank you, Rick. A little bit of a repetition of what Rick said here, if I can get the mouse going. There you go. About ONVIF, we're really committed to providing and promoting the open interfaces for the security industry. We really see that interoperability is becoming a key part in the development of our industry. And we base this activity on a few cornerstones. And naturally, that's the standardization of communication between these IP-based products. And we also focus on interoperability regardless of brand. That's the whole point, that you can mix and match any brand from the industry and make it work into one system. And we're open to all companies and organizations within or bordering to our industry. Currently, we have achieved some international recognition in standardization with the IEC and ISO. We're member as a liaison in Technical Committee 79, Working Group 12, which deals with video security systems, where we have made contributions for the entire suite of web-based or web services-based interoperability. We have also been successful with the access control standards, where we also have contributed with the ONVIF standards for web services-based interoperability. And as a little sideline of that, we have been adopted by another technical committee which deals with CCTV system in trains, where you need to get an effective connectivity when you approach a station. We are also a liaison to ISO EATC, which is the organization that develops the high efficient video coding, also known as the H2 to 65. And this will be described a little bit more in detail later on. The discussion points of today is that we will look at traditional IP video system architecture. We will look at the evolution of video codecs, the role of the compression technologies, and maintaining interoperability with new ONVIF profiles for this advanced streaming, and how ONVIF and its profile adopts to the market advancements. If we start out with the existing profile S, which is the video profile that ONVIF has been out for since 2012. It does provide video and audio streaming. It provides video configuration and multicast, and it also supports patented zoom control and relay output in those cases where the camera are equipped with it. That's what we call it with an ONVIF conditional feature. So if we look at that in a system scenario, you will typically have the network, the LAN WAN at the center. You can have the cameras out on the edges, or you can have the PCs and the servers. And as long as we can see that those products support the Profile S, you know that interoperability between those systems are provided. And it's worth noting, although the images or the symbols of the cameras all look the same, this is where one of the things are where you can mix and match between Pelco cameras or Axis cameras or Boss cameras or what have you. So building a system with Profile S, it allows the freedom of choice of mixing and matching of devices and clients. So you can pick cameras from one vendor, you can pick an NVR from another vendor. And I said it was introduced in 2012, but it was actually in 2011. And it has by now become the de facto interoperability standard for video streaming. And currently there are more than 10,000 Profile S conformant product models, not individual products, but individual models. So you can imagine the amount of devices that are out there in the field that are Profile S conformant. Oops. There we go. So we would say that Profile S is the standard for video streaming. And when it comes to codecs, it incorporates motion JPEG as a mandatory, and it includes optional support for MPEG-4 and H.264, and requires support for transport protocols RTP, UDP, HTTP, and TCP. And as all of you know, that there is a new kid on the block here, which is called H.265. So I hand over to you, Stuart, and you give us a little bit of insight in that.
Great, thanks very much, Per. So yes, the new kid on the block. I mean, let's take a moment to kind of go backwards in time first and look at where we've come from in the evolution of video codecs. So let's talk about the whole point of a codec is to take video pictures and make them smaller so that it's easier to store in a smaller space, or it's easier to transmit in a thinner pipe. That's why we have video codecs. If we didn't have constraints on storage, and if we didn't have constraints on bandwidth specifically, and we're not just talking about internet bandwidth, but also local bandwidth, then we wouldn't need to have compression. But video codecs exist to solve that problem. Back in 1998, the kind of the predominant one that we were talking about earlier that became the founding requirement for Profile S was motion JPEG. This was basically a series. It's like a flip book. It's like those child flip books where you draw a picture and you have a representation of the entire picture. Then you go to the next picture and it has an entire representation of whatever moved. That's what motion JPEG was about. And that was, it was good. It has its compression artifacts and things like that you would in if you're compressing every single picture the same way. And we moved from there to MPEG-4. Now I'm going to talk about the MPEGs, the H's, and what all that means. There's really two organizations in the world that we've been talking about some standardization. There's the MPEG group, which is a part of ISO IEC. This is the Motion Picture Expert Group. They're a group that developed a lot of standards, specifically around JPEG and things like that. But they developed a lot of standards. And there's also another group which is a part of the International Telecommunications Union, which is associated with a different kind of setting that's also working about how to do video transmission. And so those two groups were basically came together around this time to develop what is essentially MPEG-4 advanced video codec. It is also known as H.264. Now the MPEG-4 is obviously associated MPEG, the MPEG motion picture expert group, and the H is actually the designation of the ITUT, which is the video content expert group, I think is what their group is called. So we've got those two groups now working together, which is for the betterment of everybody. And we take MJPEG and MPEG-4 and we advance it into advanced video codec. It was really didn't get a lot of traction though, because it was an improvement, but it really didn't get wide-scale adoption until later on, when higher resolutions required a much more efficient codec. And we started to get into the video streaming marketplace around about 2009, when our satellite TV started adopting H.264 because they wanted to also broadcast high resolution HD video as well. Now those two groups continue to work together because we've moved on as a consumer market as well as a security market into even higher resolutions, and they continue to work together, and they've introduced H.265. Now this is also referred to as MPEG-H Part 2, but it's almost universally known as H.265, and this basically builds on the science that was developed in the previous formats and adds some capabilities. Now it was introduced in about 2013. Wide-scale adoption is going to be, we don't know yet. We just don't know. I think it all depends on a number of different things. Probably the adoption of high-resolution video in the security industry, as well as the impact on the consumer and broadcast industry as well. So, what's been driving this? Well, I mentioned it earlier. This growth and popularity of high-definition video over the last 10 years has really driven the need for more and more efficient codecs. Hard drive costs tend to be going down over time because storage is going up. So if we had no higher resolution, our actual cost of storage, cost of doing business as a security industry would still be going down as well. But at the same time, we've been introducing higher and higher resolutions. We're beginning to over and above 12 megapixel resolutions, and we've had a wider spread adoption of what we used to call high resolution, like 5 megapixel, like 4K images. We've seen that become much more the norm. In fact, I see that so often on specifications now that really is considered to be the normal level of resolution. So what is the impact of that? Well, as we start to have those higher resolutions, there's bandwidth, and it's bandwidth on the disk and storage, it's bandwidth in the transmission, and it's bandwidth in the presentation as well. So this is an increased resolution. We're starting to see the increased resolution also be paired with higher frame rates. 60 frames per second is almost universally expected on a higher end camera now. We starting to see 120. And if you go and buy your 4K TV for the holidays this year, it is not unusual to see a TV capable of doing 240 frames per second. So that's the benefit of having those higher frame rates, is that motion becomes extremely smooth. And the same applies to the security market. I think we're going to see higher frame rates come up. Those higher resolutions, those higher frame rates are only possible if we have more advanced video compression. Now, the other thing that's driving this is the fact that we're getting more cameras installed. There's more points of data coming into the system than there used to be, because as we know, there's a downward pressure on the video source capability, but there's an upward pressure on the video storage because we've got more devices and more clients coming through as well. So, excuse me, I got a bit too excited there. So this high resolution has this big impact on the storage, but I've talked about the hardware and the network as well. The network infrastructure, I remember 10 years ago we were talking about the total throughput on the backbone, and we've kind of solved that issue. But as we start to get into things like the many cameras on a system, all maybe multicasting, we've got to deal with multicast flows with significant bandwidth constraints. So our network hardware has been advancing to support this type of infrastructure too. And it is a truest statement today as ever that storage is usually the single largest expense in the video system. And despite the fact that spinning hard drives continue to have increased capacity and a decreasing cost per gigabyte, and will very soon be quoting cost per terabyte as a hard drive metric in the near term. But because those are going down, it doesn't mean that we still need more and more of these, because we actually end up with an increase in the demand and requirements from a camera capacity perspective. So what does H.265 do for us? Well, the promise and the real world measurements that we get is this reduction in the bandwidth and storage by up to 50%. So we can continue to get those same frame rates and same resolution that we had before. But if you could compare like to like the actual bandwidth consumed to various tricks that the codec does and the storage costs, it should be reducing by 50%. Now, I think that what the trend will say, what do we do with that 50% saving? I think there's absolutely going to be uses where we actually take that storage and we buy less because we need less. But the history has taught us is that what tends to happen is that we take that and we end up upping the resolution on cameras. We buy more pixels on target because ultimately we're looking for that detail. We may, in a high-speed environment, like looking outside at passing cars, for example, we may increase the frame rate so we can get more situational awareness. And at the same time with that storage, we may deploy more cameras at the same resolution and frame rate. I think those are the three things that will be happening versus just taking that storage and resting on our laurels. So some of the capabilities of the H.265 which is the high efficiency video codec. So there is an improved quality because of the way the macro blocking is no longer done in a matrix. Macro blocking is the way that the image gets processed and looked at. So the way the codecs work is that it's got to be asymmetric. So you have all of the hard work done in the encoding to make it slightly easier in the decoding, but you still need some degree of power there. But the way that in the encoding process, it looks at what's been going on in the scene, there's a codec engine, and then makes a prediction about what is going to happen next. So if you have things moving around the screen, it predicts where it'll be next. Now that prediction is then compared to the frame that comes in and the actuality, and it's the difference between those two images that actually gets digitized and sent over the network. At the decoding side, the exact same thing happens. The prediction looks at the existing frame, a prediction gets made, and then the delta that gets sent over the wire is then applied to it, and that's how the image comes up. Now, it does this in various ways, but it segments the screen essentially into all of these blocks, and it can, once it's in all of those blocks, then we apply the algorithm to each of those things. So, with that said, H.265 is a lot more efficient with macro block because it doesn't do it in a straight matrix. It does it in a shaped matrix, depending on what is going on in that screen. With that, I'm going to hand it back to Mr. Björkdahl to talk a little bit more about how ONVIF itself is leveraging Profile T.
Yeah, yes, and that's sort of part of, or the reason for this presentation also is to say what is ONVIF doing about this, and the answer to that is Profile T for advanced video streaming. Profile T was after a long period of hard work by all the brilliant engineers in ONVIF released not long ago, and it did actually require quite a lot of rewriting to be more flexible for what different manufacturers or coders, encoders you want to use. But it comes out and it supports the H.264 and the H.265 video compressions. It can manage the image settings. It can deal with motion alarm and tampering of events. It's also capable of dealing with metadata streaming, and that is extremely useful if you're talking about different type of video content analytics that's becoming more and more popular and actually more used in our industry as well, because it really brings a lot of accuracy to the interpretation of the scenarios and what's going on. And it also offers bidirectional audio. If we take a look at how this looks in reality, if we look at a typical application with an ONVIF profile, we have the client where you view the images, and you have a camera, and you can look at the H.264 motion JPEG images, and you can do some basic configuration. You can control a relay, or you can pick up some audio. And of course, if the camera has the capabilities, you can also do some pan-tilt zooming. With the H.265 and those features in Profile T, you can do that, plus a lot of other things. You can have IOs like push buttons. You can have bi-directional audio. That means you can have like a door station or a gantry where you report and you speak to the operator, and they will raise the bar for you. In addition, you get the same video codecs, and you get H.265. And you can do also image settings and HTTPS. And you can execute these auxiliary commands that most modern cameras have today. So that's quite an advancement on that side. So are those profiles compatible with each other? No, they're not. They're two different profiles, but they are complementary. And the way the market will meet that is that you will see a lot of products being conformant to both the profiles. To be S, to say be conformant with the legacy, all the NVRs that are out there, and Profile T to be able to cope with the future of video coding. One thing that Stuart didn't really mention is that there is a little bit of a tricky licensing scenario still around H.265, as it is a new organization behind it. So some of the elements that holds us back is that we don't have a very comprehensive way of licensing the use of this technology. But as we move on, Profile T, or we expect Profile T to eventually replace all the Profile S products in the market as we go forward. We talked a little bit about the feature of bi-directional audio, and I think many of you have seen these door stations coming up where you have a little box, you put it on a wall, and it's a camera, it's a push button, it's a microphone, it's a speaker. And Profile T is then fully capable of managing that device. You can enable the audio from the camera to the VMS. You can also go with the loudspeaker and the microphone to pick up what's happening. So it's a perfect product today when you want to get it to control and see and have control over the entry points to your building. So if we then take a look at the total suite of profiles that ONVIF have currently, we start from the earliest one with the Profile S in 2011, as talked about before. We talk about the Profile G, which is for edge and storage retrieval. We talk about Profile C for basic access control. We have Profile Q, quick install. It's like an installer profile. And we have Profile A for a more comprehensive feature set of access control. And as just described, we have the Profile T for advanced video streaming. So these profiles together brings you a lot of key benefits. It's easier to determine the compatibilities between those different products. You simply look at your client and your device, your NVR or your camera, and see if they match the same profile. That will ensure that they work together. So it allows the users to easily identify these specific interoperability features by just keeping a lookout for the profile. So it makes integration really trouble-free. You don't have to have extensive technical knowledge to be able to make this work. It's just sort of out of the box functionality. And the manufacturers will use the latest release of the test tool to make sure that devices and clients do conform to those products. And as a member, you have access to this tool as well to verify that it's working. So a short recap on the profiles that are available now is the Profile A for advanced access control, Profile C for IP-based access control, Profile G for media storage, Profile Q for quick installation, Profile S for IP-based video streaming, and Profile T for advanced video streaming. So by that, I think I hand over to Stuart to tell you a little bit more about the benefits of these ONVIF standards. Or actually,
Thanks.
that was too quick. No? The benefits it is. Sorry for that. Thank you.
Thanks, Per. So yeah, I mean, I think as we've aptly covered, we've got a lot of profiles that cover a lot of different areas. Under the hood, and this was referenced earlier, this is built on a service-oriented architecture, and the way that ONVIF is developed is to build leveraging other open standards as necessary. We talked about ITU and the ISO IEC group and MPEG-4, how they basically do all the heavy lifting as far as developing a video codec, and ONVIF embraces that, works with those organizations, and brings those standards to the plate. The same thing, as Per had mentioned at the very first slide, I think, was talking about how we work with IEC and the working groups that we help push there. ONVIF is built on service-oriented architecture using open standards as well, and we're able to really put together a very powerful interface specification specifically focused around the security applications that we're focused on, and it provides that what we call the interdisciplinary interoperability, which is the way that we can provide interaction between access control and video. That used to be a really big challenge, and was one of the reasons that ONVIF was formed, was to allow better information sharing in a much more standardized way, so that we can get access control data into video systems and video systems into access control, but really stop thinking of them as a separate entity and start thinking them as a single operating environment. So again, why do we come together? We want to increase that communication between conformer devices and clients. It's in the best interest of almost everybody, every demographic involved, whether it be a manufacturer, a system integrator, an end user, a consultant. By having easier communication between conformer devices, we end up basically solving problems faster and focusing on what the real value we bring as players in this security market is, which is basically protecting people and assets. So providing the ability to improve that communication between clients and devices, but also improve communication between systems that are working independently. So multiple camera systems, so you could have multiple vendors, multiple deployed cameras that are coming from different vendors, talking to multiple deployed VMSs also coming from different vendors, and having those things talk well together and operate as a single system. You can imagine if you look at a typical city, you might have the police managing the protective law enforcement focused city surveillance applications, and the traffic management group managing cameras over intersections. Or you might have the mass transit systems, or all managed separately. And with ONVIF, you can use and build a single solution around a single command center. So that's the purpose, and that's the reason that we participate in this initiative. So what does it mean from a system integration perspective? I think we know that what we're working on and what we have been able to provide is a much easier way of getting different devices from different vendors working together. So the setup's easier. We have advanced security profiles, and we've been having a working group focusing on the needs of our manufacturers and the needs of our end users from a security perspective that allows a much more cost-effective deployment to occur. Because it becomes easier to install and easier to maintain through a standards-based interface, the actual cost from a system integrator perspective should go down. That simplified installation helps with that. And it also allows for that situation when if an end user is not happy with a particular product or vendor, you can kind of do a mix and match without any fear of lack of interoperability, because ONVIF provides that single interface that all of these security products are using. So how do we ensure that we have a solid integration? Well, we've been developing really 3 or 4 different methods of doing that. The first of which is the most obvious. We have a core specification. This is where we get all of the engineering people from all of the different members driving towards a core specification where they write the technical specifications into a piece of paper, and we make that available on our website. But probably just as important, if not more important, there is how we test that, because it's all good and well having a very technical document, but how do you test against that? What do you do to test against that, and how? So we provide a test tool to our members that they can use to develop against. So that's a client test. We have a client test tool and a device test tool that then implements software to test against the specifications that we've already written. And that software automatically will give feedback about what did and didn't work, what didn't conform, and that has been increasing in the amount of tests it's performing, as well as increasing the accuracy and interoperability overall of all of the products as we've gone forward over the last few years. And the proof of the pudding is really put to test when we have our developer plugfests, and these attract participation from a lot of manufacturers and others, where we come together in one very large room with test equipment and test analysis in place, where members can work with each other, and if they need to make some tweaks or what have you, they can test their devices in a very collaborative manner. It is very interesting when you see these things going on, when you see all of these, what we traditionally see as competitors, working together for the benefit of making sure that devices work together, which ultimately benefits the entire industry, and especially the end user base that we're all targeting. So once we've gone through that, how do we get to the point where the end users or system integrators or consumers of ONVIF can ratify that devices are actually particularly ONVIF devices? Well, the ONVIF conformant list is published on the ONVIF website. That is the place to go. That is the central repository. You want to know a product is ONVIF conformant, you should go look up that model number on the ONVIF website. If it's not there, either the manufacturer has not submitted it for conformance, or it's waiting. And it does happen time to time that there might be a mistake being made, and if there is a mistake being made, then we actually also have a form where you can report that mistake, and we have a process for allowing people to report improper conformance claims. So if you have a question about a product, you can go and look at that product on the ONVIF website. You can check which profiles, because it could support one or many profiles, are actually conformant on that device. And you will see the test tool version, you will see the product firmware version from that manufacturer, and that's the way that you can verify for sure that this device is ready to go with conformance. Now, with that being said, I think we've come to the end, and we'll be taking some questions.
Thank you, gentlemen. That was very interesting. I do have a few questions here, and let me begin. And I'm not sure who wants to answer this. Stuart, this may be you, but you can decide. Do you think H.265 will be adopted by the masses faster than H.264? I know it looked like from the slide it took about 6 years to get to adoption of 264, and it's been almost 6 for 265. Do you think there's going to be some speed up here with H.265?
I personally do, yes. I think it will go a little bit faster, and that's why I'm hesitant to make the prediction. My feeling is that there's when we made the transition from analog to digital in video, we kind of kept essentially the same kind of streaming resolution. Then when we bumped it up and we started heading into the megapixels, and we started hitting the back end of compression and bandwidth capabilities. Since then, network switches, pipes, storage capacity, all of these have been keeping pace when it wasn't, in my opinion, keeping pace as much back in that initial transition. 265 is also being deployed in video streaming in the consumer space a little bit faster as well. So I think that it will be adopted faster. I don't know when that will. I'll be able to say it will be there, but I think with the race to 4K content everywhere that we're seeing in our consumer lives as well as our video security lives, I think it's going to be probably 2 to 3 years versus 6.
I want to add to that also that the the shift from motion JPEG to H.264 was a much bigger leap than it will be go from H.264 to 265 from the processor capacity you need in the devices. So that really also supports the fact that it will probably be quicker than going from motion JPEG to H.264.
Sure, sure. Do either of you see any major stumbling blocks to the adoption of H.265?
You go first, Stuart.
Yeah, I think sure. I mean, the obvious ones are going to be, making sure that all the pieces are in place. Initially when you look at the encoding, decoding, as I said earlier, it's asymmetric. So you do need to have the horsepower on the encoding end. I think with modern chips and processors that are coming out, that's not really an issue, but it always is initially. And I think we've actually got to that point faster than we ever have in the previous transition. I think probably if there's a big shift and direction change to even higher resolutions, there might be a cost benefit discussion that goes on, but I think this is, like Per said, I think this is a much easier transition, and I think the benefits really outweigh a lot of the technology investment costs. And frankly, if you're making devices these days, this stuff kind of comes all in anyway. It's a much easier stepping stone than it was in the past.
Sure.
Yeah, and also given that you get some other features out of H.265, like pre-processing for video content analytics, so that sort of motivates and justifies also the investments to be more rapid.
Another question, can we expect an updated ONVIF device manager application with Profile T support?
I think I don't exactly know which ONVIF manager you're talking about, but the test tool is already upgraded. That's always taking place in sync, so that the test tool for both client and devices will be fully compliant with the profile, in this case Profile T, when it is released. Are you thinking about the VMSs or in particular?
I think the ONVIF device manager is actually that third-party device thing that's available on SourceForge and a few other.
Yes, of course,
yeah.
yes.
So that's actually not a ONVIF project per se. You want to tackle them?
Yeah, but it's hard to say. It's on SourceForge, and I know that a lot of integrator uses it. So
yeah,
I don't think we're saying the wrong thing. That is most likely going to be updated as well.
Yeah,
it's sort of that's the whole point of open source like that.
Okay.
But as Stuart says, it's not a development that is made by ONVIF.
Okay, good. Another question, is there any drive to accelerate the take-up of Profile Q? Take-up is still seems to be quite sparse.
You want to go on that, Stuart?
Sure. Yeah, I mean, I think ultimately it's up to the manufacturers who are members to decide whether they want to see Profile Q in their products, and ultimately a lot of the manufacturers are driven by what they're seeing in the marketplace from a specification perspective. I know there's quite a few manufacturers who have implemented it, and there's a few that are still to do so. I think it's personally, I think and Pelco is a driver of that particular part of the standard, but I think it's a very valuable one from a deployment perspective. And I think, to be honest with you, with Profile T's deployment will actually help the adoption of Profile Q, because people will start to incorporate. It's a good transition point to start to see new specifications around ONVIF being written, and the value and the investigation that will come from learning about Profile T will also expose people to Profile Q, which will allow those specifications to get seen more and more. So I actually expect there to be kind of a pull-through benefit for increased adoption of Profile Q.
I think you're right, Stuart. When as the acceptance of the use of ONVIF various profiles continue, Profile Q is a focus on quick deployment. So if you're doing multi-camera systems, hundreds of cameras, there is time to save by using Profile Q. And time, as you know, in our industry is also some competitive edge. So it sort of talks for itself that profile Q has a place there.
Okay. Another question. ONVIF Profile G does not seem to support video downloading, does it?
Downloading from where? From the disk to a client, or?
I don't know. I'm just reading the question here.
So
okay.
ONVIF, yeah, I mean, I'll take a stab at this, and you can correct me if you're wrong. But I think it depends on how you look at it. So just from a ONVIF provides ONVIF G provides essentially an access to view what video is available, and then it can use other parts of the standard like Profile S to actually get access to that video. So the download could be an implementation using those two profiles. So if you want to be able to download it, do a kind of an export and a download, if the export file is exposed as a response by the manufacturer in Profile G, then it should be able to stream and download it. But that's more of an implementation question that the manufacturer's VMS would offer.
Yeah, because one of the ideas behind Profile G was that you could have a hard drive somewhere on your network, and then from the client side you can download that content as you go. And we do have some VMS manufacturers in ONVIF that have created like a Profile G shell around their entire VMS. That means they are interoperable from the outside using ONVIF. Okay. So it's actually a way to expose the content for downloading by other clients.
Okay. All right. Good. This isn't really a question. It's a comment. It says ODM has not been updated since 2013.
Yeah, that'd be the ONVIF device manager again.
Yeah. Okay.
Well, as we said, it's not a tool that is developed by ONVIF. It's an open source. We could, I don't know. It's really up to anyone out there to do that. We use the device manager to encourage people to, or not device manager, test tool. Test tool can be used for similar features to verify and to do some settings in the product.
Yeah, so just to be clear, that we didn't start the open source project either. It was somebody. I mean, it's some enterprising individual. I'm not quite sure who it is, but they started it, and we know it exists. And we as an organization, we support anybody starting open source projects using the specifications. But like Per said, the tool that we use is the ONVIF test tool.
Okay. All right. Good. So just circling back to that video downloading on G that we were talking about earlier, follow up here. Yes, the person is asking about a client device, downloading to a client device. And it says export is applicable for NAS storage.
Mm-hmm. Mm. So the answer is, does G prohibit or not allow that to happen? The answer is no. It is supported, that type of use case. This is the difference between having an interface that supports something and having the manufacturer of the product implement that feature or that capability using the interface. So I think the answer is yes, ONVIF can support that, and I would advise you talk to the manufacturer to make that feature request in the application that you have.
Yep. Good idea. So in your crystal ball, what kind of impacts or advancements to camera or VMS technology do you see when H.265 and Profile T reach that mass adoption phase that we were talking about? Additional or more robust edge analytics or other features that were limited because of bandwidth constraints?
Yeah, we will see advancements for sure. I mean, we all live by the philosophy of Moore's law, that the more process capacity we get, the more we can do. And as mentioned earlier, the H.265 has in its development taken some considerations to video analytics, sort of pre-processing, which makes it much more easier, where you can pre-process and single out certain elements already on the silicon itself instead of bringing it into a server and doing a lot of processing to find that. So of course the capabilities to develop new smarts will definitely bring this forward.
I think one of the things that we'll see, and we may not be seeing it right now in the initial phases, but I think we'll actually start to see implementations provide a much improved use of the technology. A couple of examples spring to mind. When I look at H.264, it had some very interesting pieces of technology that never really kind of made it into the mainstream, particularly the way it dealt with slices and staged compression. In H.265, one of the very cool capabilities that the specification has is the ability to leverage kind of essentially multi-threaded or multi-processor decoding. What that means is that different parts of the image can be decoded simultaneously versus all at once, and slightly different than the iSlices worked in 264. But this capability should allow for improved latency on the decoding end, because we'll be able to as our processors have been developing into these multi-processor BMAs that they are today, we can take advantage of that technology in video coding. So the more cores that and multi-threaded things that either a CPU or a GPU has, we'll be able to get a lower latency built into the decoding pipeline.
Okay. Can Profile T provide a migration path to a full H.265 system?
Almost, I would say. If you have motion JPEG products, they're not supported by Profile T. But I would say I can't really say that we do have any products out there that are only motion JPEG. Do you know that better than I do, Stuart?
There might be a few. I mean, you're talking 2011, so a 7-year-old camera that might have only motion JPEG. But I mean, I think if you have a 5-year-old system today, I think you'll have a path forward with that 5-year-old system, because I think only the early ones were MJPEG only.
You will have dual support for MJPEG and H.264. And if the question is, or the answer to the question is that, can Profile T provide a migration part very soon, if not now?
Okay, good. One last comment here about ODM. Someone has commented that ODM was developed by a company called Synesis, Synesis, in either Russia or the Ukraine, and the company doesn't seem to exist anymore. So that probably explains why it hasn't been updated since for several years. And with that, we have wrapped up the questions. I do want to let people know that this session has been recorded, and everyone who registered will receive an email with a link to the recording. So please feel free to share that link with anyone in your organization or anyone who you think might be interested. It is free for sharing. I want to express our thanks once again to our expert presenters, and thanks to our sponsor, ONVIF. And thanks to all of you for joining us today. Happy holidays, and we will see you next time.
Thank you very much, Rich, for giving us the opportunity.
My pleasure.